Good morning. All right, so we're going to pick up where we left off in 10.8 yesterday, finish out example 1. I've only got a couple more examples to do in this section, and then just a couple of examples in 10.9. So that's the plan for today, is to finish up Unit 10. Don't forget that Test 5 is up if you want to work on that anytime between now and tomorrow night at midnight. Just make sure that you submit it by then. Again, you do not have to use respondents for this one, right? So it's just there. You can download it. You can even print it out and just do your work on that if you want to. But again, you'll just scan and upload it like you would any other test. And again, just make sure you do that by midnight tomorrow night. The other thing that's due by midnight tomorrow night is the 10.1 to 10.3 homework. We've definitely covered all of that material, so make sure you get that done. I'm not going to count the 10.8 and 10.9 homework. I have it set to be due next Friday. But you don't have to complete it. Okay, I'm going to leave it open in case you want any additional practice problems, but it's not going to actually go in the grade book. Okay, so it is there. You can feel free to work through it, use it as practice, but again, it won't count as a grade. So between now and next week, you need to focus on Test 5, 10.1 to 10.3 homework, and then the final exam. And again, if you have not scheduled a time for your final exam, please make sure you go in and do that before tomorrow, because I kind of need to know, by the weekend when people are planning to take their exams. Okay. Any questions, comments, concerns before we get started? And like I told you, next week, there's no required class meeting, but I will be going through the exam review on Monday and Tuesday of next week. So if you want to see any of those problems worked out, that's when we will do that. So again, feel free to schedule your exam for later in the week if you want to stick around for the exam review on Monday and Tuesday. Okay, and that'll be at normal class time. And I still will have student hours next week also. So if you do need to come and ask me any questions outside of that time, my normal student hours, I will be there. Okay. All right, so let's look back at example 1 now. So remember, we said we can use any of the methods that we used prior for these nonlinear systems of equations. Now, in this case, final will be very similar to specific problems from the review. Again, the review is over 30 questions long. The final exam is only going to be 10 questions, and it'll be a couple of questions from each unit. So just know that, yes, they will be problems that are similar to what's on the exam review, but obviously not as long as the exam review. Okay? Yep. All right. So in this case, we can't use elimination because we don't have an x squared or a y squared in the second equation. So there's no way we can eliminate variables here. So we have to use substitution on this one. So what we did was we solved this the second equation for y, and then we substituted that into the first equation so that we got something that was just in terms of x, right? And so that's where we left off, was getting down to that equation. Once we get to this point, the 10x squared minus 60x equals 0, how would we solve that? Good, right? So we have a common factor here. All right, so we can factor out the x. We also have a common factor of 10. So I'm going to go ahead and factor out 10x. That would leave us with x and a minus 6. Right, now that we have our factors, now we can do what? Okay, so we don't actually want to move the 10x, right? Once you factor something that's equal to 0, what do we do at that point? Okay, so we don't want to divide anything, right? So good, set each factor equal to 0, right? So I'm just going to take this first factor, which is 10x. I'm going to set that equal to 0. And we're going to take the other factor, x minus 6, and set it equal to 0 also. Now, when we solve this first one here, what are we going to get? 0, right? Because we divide by 10, x equals 0. And then the other factor is going to give us what? Positive 6. Good. Okay, so we actually get two different x values this time, which tells us then that there could be 2 points of intersection for these two equations. Now, once we have the x values, we still need to know the corresponding y values, so we have to plug these in. Easiest place to do that is right here, since I've already solved that equation for y. So I'm going to start by plugging in the 0. So we're going to get y equals 3 times 0 minus 10. And so what would that give us? Negative 10, right? 0 minus 10, y equals negative 10. Then I'm going to substitute the 6 and do the same thing. So y equals 3 times 6 minus 10. And so what would that give us? Good. 18 minus 10 should give us 8. So now, what would be the two ordered pairs that are solutions to the system then? Good. So 0, negative 10, because when I substituted 0, I got negative 10. And then when I substituted the 6, I got 8. So we actually get two different points here, and both of these are solutions to this system. Now, keep in mind here, that first equation is going to give us what if we were to graph it? So the x squared plus y squared equals 100. What would that look like if we graphed it? It's a circle with a radius of 10. Good. And then if we were to graph this second equation, it's going to be a what? A line. And so graphically, right, and you could put this in Desmos and actually look at it, but we basically have a circle with a line going through it like this, and that's how we end up with two different points of intersection. So with linear equations, your options are either you have one point of intersection, no points of intersection, or they're the same line. But now with nonlinear systems, if you've got a circle and a line, it could intersect at 2 points, 1 point, or no points, right? We could also have like parabolas and lines that are graphed together. Same thing. They could intersect at 2 points, 1 point, or no points. We could also have two parabolas that are graphed together. So just keep in mind that depending on the scenario, there could be multiple points of intersection, so you could have multiple solutions to these now. Any questions on that one? Yeah, so anytime you've got a two variable system, write it as an ordered pair. And then if it's three variables, x, y, and z, then you're going to write it as an ordered triple instead, right? But in any case, that's the way I want your solution written out. Any other questions there? All right, so let's look at example 2 now. So again, we want to find all solutions of the system. This time we're going to use our elimination method though. If you notice this time, we've got an x squared in both, we've got a y in both, so we can use elimination to cancel out one of our variables here. So plug both of the variables into the same equations. So Haley, when you ask that, I'm going to go back. Are you asking about the x values that we found down here? Do we plug them back into the same place? Yeah, right. And it really doesn't matter. You could have technically plugged them into the top equation if you wanted to. I just noticed that the easiest place to substitute was the y equals 3x minus 10. But no matter which equation you plug them into, you're going to get the same value regardless. Okay. All right. So now, if I wanted to use elimination on this one, right, and we can choose either variable to eliminate, it doesn't matter because, again, I could eliminate the x squared. I could also eliminate the y here. So what would you want to eliminate, and then what would we need to do to make that happen? right, so if we do this, then if we want to eliminate the x squared, you say multiply by each other. So what am I multiplying the top equation by then? All right, so we'll multiply that one by 5, and then I would have to multiply the bottom equation by what then? Okay, and remember, we need one to be positive, one to be negative, so that when we add them together, they cancel out, right? So I'm going to use a -3 instead. Good. Now we just have to remember to distribute that to all of our terms. So we're going to end up with 15x squared, and then a plus 10y, and then 5 times 26 should give us 130. All right, and then if we distribute the -3, that'll be a negative 15x squared. We'll have a minus 21y, and then -3 times 3 should give us a -9. Right, now we're going to add those two equations together. And so when we do that, what should that give us? Good. So we get a negative 11y, and that's equal to 121 now. So now when we solve for y, what should we get? Good. So divide by -11, y is going to equal -11. Now once we have our y value, now we can do what? Good. Solve for x. And again, it does not matter where we plug it in, which equation you use. So which equation do you want to go with this time? All right, top one. So we'll get 3x squared plus 2 times -11 equals 26. Go ahead and multiply the 2 times -11 here. So we have 3x squared minus 22 equals 26. So then we can do what? Good. Add the 22. When we do that, that should give us 48 over here now. And then you'd have to do what? Good. Divide by the 3. So x squared equals 16. And then what's our last step going to be here? Good. Take the square root of both sides. So when we do that, what are we going to get? Perfect. Don't forget, it's going to be a plus or minus 4 when we take that square root this time. So we need both the positive and the -4. All right, so now when we actually write the ordered pair or ordered pairs this time, what would that look like? You got it. So we take the positive 4, that goes with -11, but then we also have a -4 that goes with -11 as well. So we have 2 points of intersection this time. Both y values are -11, but the x value could be positive or -4 in this case. Now, just to think about visually what this would look like, what would both of these equations be if you were to graph them? What shape would we have? Okay, it's a parabola, right? So in this case, we have an x squared, but we have y to the first power, so it's not a circle anymore. So these would both be parabolas. In this case, if I were to move the 3x squared and the 5x squared to the other side, it becomes negative. So I know these are going to open down. So what happens is we basically have a parabola that looks like this. And then we have this other parabola that looks like this. And so we get these, and they should be symmetric. Sorry, I messed that up. Okay. But they should be symmetric like this, where we get these 2 points of intersection on either side. And again, you could put this in Desmos and actually see that and find the points of intersection that way. But those would be your 2 points of intersection if you were to graph those. Any questions on that one now? All right. So now example 3, we're going to do this by graphing, right? So we want to find all solutions to this system. We have x squared minus y equals 2, 2x minus 1 equals negative 1. So again, we have the first one with an x squared. That's going to give us a parabola. Second one here, we have an x and a y to the first power. That's going to give us a line. So we have to think about, what this is going to look like. But in this case, we're just going to go to Desmos. We're going to graph them both, and then we'll find our points of intersection that way. All right, so our first equation, we have x squared minus y equals 2. There's our parabola, and then we have 2x minus y equals negative 1. There's our line. Now, always be careful with your viewing window, right? I'm way zoomed in because I was working on a different problem before. So I'm actually going to zoom out now so that I can see what this looks like. And you can see in this case that the more I zoom out, that line is looking like it might cross over the parabola again. And so we actually do end up with 2 different points of intersection. So always make sure you're finding all of them. So we're going to have this point right up here as one of our solutions. This point right down here is the other solution. So we have 3, 7, and we have negative 1, negative 1. Now, on the test, I expect you to do these algebraically, so I want you to use either substitution or elimination when you're finding those points of intersection, but you can definitely use Desmos to help you out to make sure, right, that you found the correct points. So always feel free to graph them, find those to check your answers. Any questions on that one now? All right, so that's all there is that we're going to do in 10.8. Let's look at 10.9. All right, so 10.9 now we're looking at systems of inequalities, right? So we started with just basic linear equations, then we looked at some 3 variable systems, then we did things that weren't linear. Now we're going to say, well, what if we have a system that's not even an equation anymore, right? And so we have inequalities instead. What would those actually look like? Now, the first thing we have to understand is how do we even graph an inequality? So we're going to start with that, just looking at individual inequalities. Then we'll start looking at, now what if it's a system of inequalities with multiple inequalities on the same graph? What do those solutions look like? Okay, so now the first step to graphing an inequality is you're going to graph it as an equation, right? So you're just going to think, well, what if that was an equal sign instead? What would that graph look like? Now, if you have a greater than or a less than, we have to make sure that the curve or the line is dashed. Okay, so we're going to make sure we use a dotted or a dashed line for those. If instead we have greater than or equal to or less than or equal to, then we're going to make it a solid line instead. So just that's the one key difference between just graphing a regular equation and an inequality now, is we have to make sure if it's just greater than or less than, it's dashed. If it's greater than or equal to or less than or equal to, then we make it solid instead. Once we have the curve or the line itself graphed, then we have to choose a point somewhere on our graph and plug it in to see if we get a true statement. If we do, then we're going to shade everything towards that point. Okay, so basically, let's say I graphed a line, and as long as 0, 0 is not on that line, I'll plug in 0, 0. If 0, 0 makes it a true statement, I'm going to shade everything towards 0, 0 on my graph. If we get a false statement, right, and the inequality is no longer true, then we would just shade everything away from that point that we plugged in instead. We're going to go through the steps, right, and actually do one of these. Okay, but those are kind of the two key things. Dashed if it's greater than or less than, solid if it's greater than or equal to or less than or equal to, and then we have to make sure we shade our graph, and we can just choose a test point to figure out which way we're going to shade. All right, so let's take a look at this first one here. We've got x squared plus y squared is less than 25. So the first thing we're going to do to graph it is we're going to think of it as an equation. So if this was just x squared plus y squared equals 25, what would that look like? It's a circle, right? What do we know about that circle? Okay, it has a radius of 5, right? Because don't forget, r squared is equal to 25 in this case. When you take the square root, though, the radius would be 5, right? What else do we know about the circle? Where's the center of this circle? Good, it's 0, 0, right? So the origin would be our center because we're not adding or subtracting anything to the x or the y value. So we know we're starting from the origin. So basically from the origin, I'm going to go out 5 units in all directions, and then I'm going to sketch my circle. So we'll go 1, 2, 3, 4, 5 this way. That's going to be a point on my circle. 1, 2, 3, 4, 5 in that direction. There's another point. 1, 2, 3, 4, 5 over here. And then 1, 2, 3, 4, 5 down here. Now, before I actually sketch, we have to think about whether this is going to be a solid curve or a dashed curve. So what is this one going to have to be this time? Dashed. Good. So remember, if it's less than or greater than, if there's no equals on it, then we have to make sure we make it a dashed curve. So when you draw your circle now, just make sure it's dotted or dashed. So we get something like that now. Any questions just on that part? That's step 1. Okay, now step 2 is we have to shade. So we've got to figure out which way we're going to shade this one now. So again, if you know, you know, and that's fine, you can just shade it. But if you're unsure about which way to shade this one, we can choose a test point and see if it's a true statement. What's a point that I could easily plug in here to see if it makes a true statement or not? Okay, you could, right? But we need an x and a y value. So what would be easy x and y values to plug in here? 2, 2 is fine, right? I was going to go with 0, 0, right? Because I know that's just going to give me 0 on the left. But you can use whatever points you want as long as they're not on the circle. That's the key, right? So it has to be either outside the circle or inside the circle. If you want to use 2, that's fine. 2 squared plus 2 squared. We want to know, is that less than 25? Well, what would 2 squared plus 2 squared give us? Okay, good. So 4 plus 4, that's going to be 8 overall. So the question is 8 less than 25? Yes, right? So the point 22 would be right in here now. So that tells us because we get a true statement, we want to shade everything towards that point. So where are we going to shade our circle now? Inside or outside? Inside, right? Since 2, made it a true statement, that means we need to include that in our shading. So we have to shade everything inside the circle this time. Now, another way to think about it, right? All the points that are inside the circle, when you add the X and Y values and square them together, that should be less than the radius squared, right? And so then anything bigger than that outside the circle, that's where it's going to be a false statement. So we don't want to shade anything outside the circle this time. But if you had just flipped the sign and made it greater than instead, then the only thing that changes here is everything outside the circle gets shaded, everything inside would be blank. Okay. So just notice here, what this tells us is this inequality technically has an infinite number of solutions. It's all the points that are inside that circle now would make this inequality true. That's why we have to do a graph and we have to shade, because we don't have a single point as a solution, right? We can't just write out all the points that would work here. Any questions on that one? All right, so let's take a look at the next one now. So we have x 2y greater than or equal to 5. That is the answer. That's right. Yeah. So if you're just asked to graph an inequality, that is your answer, right? It's just the graph. Again, make sure you make it dashed or solid based off of whether it's got an equals or not, and then make sure you shade. Okay, those are the two things you got to do. Okay. All right, so let's look at the next one now. So x plus 2y greater than or equal to 5. So how are we going to graph this now? All right, good. So go ahead and solve this for y, right? So I'm going to move the x over. So we get 2y greater than or equal to negative x plus 5. Then we can divide by 2. Just be careful. Make sure you divide everything by 2 when you do that. So we're going to get y is greater than or equal to negative 1/2 x plus, and then this is going to become 5 halves now. Yeah, so go ahead and get it in slope-intercept form, right? It is a line, and that'll help us to actually graph it. Okay, so what do we know about this line now? Okay, good. We know the slope is negative 1/2, right? And the y-intercept is going to be 5 halves. So we're going to start at 5 halves on the y-axis. We're going to do our slope of negative 1/2, and then we have our line. Okay, so I'm going to go up to 5 halves. That's the same thing as 2.5. That's halfway between 2 and 3. So that's going to be this point right here. Then our slope, negative 1/2, tells us we're going to go down 1 and to the right 2. Down 1 to the right 2 is going to put us right here. Now we just need to know, is this going to be a solid line or a dashed line? So what do we think this time? This one's going to be solid. Good. Because it has the equals on it this time, we have to make sure it's a solid line. We have our solid line going through those 2 points. Something like this. And now we just have to figure out which way we're going to shade. Okay, so what's a point we could plug in here to help us figure out which way to shade this graph? Okay, 0, 0 again works, right? I'm going to go back to the original up here and say 0 plus 2 times 0. We want to know, is that greater than or equal to 5? Well, 0 plus 2 times 0 is just 0. Is that greater than or equal to 5? It is not, right? So what does that tell us then about the way we're going to shade? Okay, good. The top is going to be shaded because we need to shade everything away from the point 0, 0. So that means I'm going to shade everything in this direction since 0, 0 did not make it a true statement. Now, again, you could just recognize, oh yeah, y is greater than or equal to negative 1/2 x plus 5/2. That means I'm going to shade up, right? So that's everything above the line this time. And so that's how we get that shading. So you don't have to do the substitution, but if you're ever unsure about which way to shade, pick a point, plug it in, see if it's true or false. That'll tell you which way to shade your graph. Any questions on that one now? All right. Now, the solution of a system of inequalities. Okay, so if we're looking at the solution of a system of inequalities, again, the only way we're going to be able to do this is by graphing, because we're going to have an infinite number of points. We can't actually just list them out, right? We have to do it by graphing. So the first step is just to graph each inequality, right? And that's exactly what we just did on the previous example. So that's step one. Then it says we're going to graph the solution of the system. What that means is we're going to find the overlapping region between the two things that we've shaded at that point. Okay, so we're actually going to put both or all of them if there's more than two, right? However many inequalities you have, put all of them on the same graph. Then you're just going to look for the overlapping region of all of your inequalities. That's going to be the solution of the system. And then the last step is what we call vertices. Okay, so in this case, that's the points of intersection. So we would find those points of intersection for all of our equations, or sorry, inequalities within the system now. So graph them both on the same graph, figure out where the overlapping region is, that's the solution, and then find the vertices, the points of intersection between all of your inequalities. All right, so let's take a look at this one now. We just want to graph the solution of this system, and then we'll label the vertices. Now, these are the same two inequalities we just looked at. The only difference now is it's a system of inequalities, so we have to put them together on the same graph. So I'm just going to go ahead and start by graphing that first one. And again, it's exactly like what we just did. So we're going to have a circle, radius of 5. It has to be dashed because there is no equals this time. So I'm just going to go out 1, 2, 3, 4, 5 in all directions. I'm going to do my dash circle. Now, once we have that, right, we know that we shaded everything inside here. So I'm going to go ahead and put that shading on here also. Right, now, this time, since it's a system of inequalities, the next step is we're going to graph that other inequality right on the same graph here, right? So I'm going to change colors just so it's clear, it stands out which one is which. Okay, so remember, this gave us y greater than or equal to negative 1/2 x plus 5/2 when we solved it. So we go up to 2.5. That's this point right here. We go down 1 and over 2. Going to give us a point right here. And then we're just going to draw our solid line this time because it's greater than or equal to through those points. So we end up with a line that looks something like this. And remember, this time this was shaded above, so we're going to shade everything above this line now. Any questions up to that point? Let's just putting the two graphs we already did just on the same graph now. Okay. Now, that is not what we want, right? Because we only want the overlapping region to be shaded. So I'm going to have to draw a separate graph now that only has the solution. If you can do all that in one step, feel free, right? Okay, but if you need to actually draw one graph where you shade everything and then draw a separate graph where you just have the overlap, that's perfectly fine too, right? So whatever works for you. Now I'm going to do my graph that is the actual solution because I only want the overlapping region. So again, go up 5, all directions here. Dash circle. And then I'm just going to go ahead and put my line on here. And then we'll talk about where the overlap is. All right, so looking at what we've got now on that first graph, if I only want to graph the overlapping region, where's that going to be? Just kind of describe it to me. Okay, good. Everything that's above the line, but also inside the circle now, right? So it has to be just this stuff right in here. Like I said, if you can go straight to that, I'm great with that, right? But if you need to graph each one individually on the same graph first and then see where the overlap is, do that, but then make sure that your final answer looks like this, because our final answer should only include the overlap. Any questions about that now? Okay. Now, the other piece of this is we need to find the vertices. And again, the vertices in this case are just the points of intersection of our two inequalities. So I notice this time I've got a point of intersection right up here, and I've got a point of intersection somewhere down here now. And we're going to do this algebraically. So if I want to do this algebraically now, how would I find the points of intersection between those two? Okay, good. So we could use substitution or elimination. Can we use both in this case? We can't, right? Elimination's not going to work because our first inequality has x squared and y squared. We don't have an x squared or a y squared in the second one. So this time we have to use substitution. Now, if we use substitution here, what variable should we solve for? Okay, that's fine. So we've already got y equals down here, right? So think of these as equations at this point, right, when we're solving them. So we've already solved this for y. So if we just want to use that, we can. Then we would have to substitute that back in. Now, just a word of advice, because of the fractions and knowing that when I substitute it in, I'm going to have to square all this stuff, I personally would probably solve this for x instead. That way I don't have to deal with the fractions when I square. All right, it's pretty easy to get x by itself here. Just move the y and get negative 2y plus 5. But either way is going to give you the same answer, right? It's just this way we wouldn't have to deal with fractions. Now I'm going to substitute that into my top equation. So we'll have negative 2y plus 5 squared plus y squared equals 25. And again, I'm just thinking of these as equations at this point to find those points of intersection. Now, if we square negative 2y plus 5, what are we going to get? Remember, that means negative 2y plus 5 times itself, right? So if we were to FOIL this, what would that give us? All right, so we got negative 2 times negative 2 should be 4y squared. Outer and inner terms are going to give us negative 10y, so that's negative 20y combined. And then 5 times 5 is 25. Okay, now we know this is 4y squared minus 20y plus 25 plus y squared equals 25. Now, combining like terms here, what are we going to get? Okay, good. So we have 5y squared minus 20y plus 25 equals 25. So then you would need to do what next? Okay, so move the 25 over, right? So I'm going to actually subtract 25 from both sides. That's actually going to cancel on both sides. We'll have 5y squared minus 20y equals 0. And then we can do what? Okay, good. So we have a common factor of 5y. It's going to leave us with y minus 4. Now that we have our factors, what do? Good. Set each factor equal to 0, which is going to give us what values now? Good. Y equals 0 and y equals positive 4. All right. Now that we have those, what do we do next? Good. Now we need to solve for x. Luckily for us, we've already solved an equation for x, so we can plug right in there. So we'll have x equals negative 2 times 0 plus 5. That would give us x equals what? Good. And then if we plug in the 4, we have negative 2 times 4 plus 5, and that would give us what? Good, negative 3. Now that we have those values, what are the points going to look like? Good. So 0, and that would be this point right over here. And then negative 3, 4, that would be this point right up here. So those are the two vertices for this system of inequalities now. Whenever you're doing these, we only need to find the points that are intersecting that are part of the shaded region, right? So let's say you had something where you had 3 or 4 different inequalities. You don't have to find all the points of intersection. You're only looking for those points of intersection along the boundary of the shaded region. Any questions on that one now? Okay, so just so you know, on the test, right, that's what I would expect. That's like number 5 on the test. You're going to actually, graph it, find the overlapping region, be careful with your dotted and solid lines, right, that kind of thing. Then you're going to algebraically find the vertices, right? So just make sure you're showing me the work for finding those points of intersection on number 5. All right, that's it. Okay, so that's all we're going to cover. That takes care of everything. Again, just make sure you understand, this test is open note, open book, all that stuff, right? But the final exam will have some questions from this unit on it, and that is not open book, open note. So just make sure by next week when you take the final exam, you're prepared to do questions like this, like the ones that are on the test, without having your notes and book available, okay? Again, just a reminder, if you haven't already signed up for an exam time, please make sure you do that by tomorrow. The link is in the announcement section. If you have any questions about that, let me know. If you need to change your time, again, just email me and let me know that too. Or if you forget what time you're supposed to take it, I can also let you know that. I will have student hours throughout next week, so feel free to drop in and ask me questions if you need to during my student hour times. We will go through the exam review on Monday and Tuesday. So keep that in mind as you're scheduling your exam if you want to participate in the exam review, okay? If you don't have any questions for me, it has been a pleasure teaching you all this semester. I know I'll see most of you on Monday and Tuesday anyway, but I just wanted to get that out there since this is technically our last day of actual class. Good luck on your test. Good luck on your final exam. Good luck on all of your final exams, and have a great weekend.